Hello, Math 3 Honors. This is lesson 3.3, Properties of Logarithms. So most calculators only have two types of log keys. One for base 10 logs, which are sometimes called common logarithms. So that's the one on your calculator that says log. And then one for natural logarithms, which are base E, and that one is ln on your calculator. Although those two logs are probably the most frequently used, you will need to evaluate logs with other bases sometimes. So in order to do this, you can follow the change of base formula. So if you have a log that you need to calculate in a different base, let's say that you needed to know log, missed my O. Let's say you needed to know log base 3 of 7. There's no button for log base 3, so we could use a base 10 logarithm. And in our calculator, we could evaluate the log of 7 divided by the log of 3. So if you want to, so that's called changing the base because our original log was in base 3, and now we have base 10 logs that our calculator can handle. So if you type that into your calculator, log of 7, need to type it in, divided by the log of 3, your calculator can calculate that, and it is 1.771. So that works. You can change it into base 10 if you like, base 10, or you could actually type it or use the natural log button as well, and it would give you the same exact result. So if you typed in natural log of 7 divided by natural log of 3, you would also get 1.771. So this change of base formula allows you to use your calculator to calculate logs in other bases. So what I try to remember, or how I remember this, is the base goes to the basement. Log base A means that you're going to have the log of A on the bottom. So here's another quick example of this. We want to calculate log base 4 of 25. We are going to round our answer to the nearest thousandth. But before we do that, let's estimate it. Remember that logs are powers. So when we are trying to calculate log base 4 of 25, we're trying to think about like what power of 4 is going to give us 25. And that's what we're looking for, is this power. So you probably know or remember that 4 squared is 16, and 4 to the third, maybe you're not exactly familiar with that one, but 4 to the third is 64, and 25 is between those two. So we would expect that our answer is somewhere between 2 and 3. Maybe somewhere in the neighborhood of 2.2 or something. So that maybe is your estimate for this log. So since we want to calculate it and round it to the nearest thousandth, in our calculator, we would say, what is the log of 25 divided by the log of 4? And it is 2.322 if we round to the nearest thousandth. So our estimate of 2.2 is pretty close. And if you prefer natural logs, you could use the natural log button as well to get that same answer. All right, so that is change of base. So there are 3 other properties of logarithms that you'll have to use as you work with logs. So they are the product property, quotient property, and the power property. So logs just have kind of their own set of rules that they follow, and they're somewhat related to exponent rules since logs are the inverse of exponentials, but they are their own thing. So if we have the log of a product, like something times something else, we can write that as the log of the first factor plus the log of the second factor. So a numeric example of this would be that if we had the log of let's see, we'll do base 2, why not? The log base 2 of 21, that would be exactly the same as the log base 2 of 3 plus the log base 2 of 7. And that seems so weird, but it works. You should try it in your calculator. In fact, just to make it easier, let's change it to base 10, because then we can just type it in really quick. So log of 21 is 1.3222, and then log of 3 plus log of 7, so let's type that whole thing in my calculator, hit enter, it is also 1.322. They're the same. All right, so that was called the product property. The quotient property is for when you have division. So if I have the log of u divided by v, that's the same as the log of u minus the log of v. Now this is different than change of base. So change of base was if we had something like this, we could calculate it as log v over log b. That's different. This is not the log of a quotient. This is the quotient of two logs. So this is a log divided by another log, and that is not the same as this. What we're talking about now is if we have a log and it is the log of, some division. So, if you wanted to kind of verify that that works with your calculator, you could think about the log of 21 divided by 3. So 21 divided by 3 is 7. And using the quotient rule, that should be log 21 minus log 3. So let's check in your calculator to make sure those two things are the same. Log of 7 is 0.845. And if I type in log of 21 minus log of 3, I get that same thing. So that's just a little numeric verification there. All right, so the last one is the power property. And that says that if you have the log of u to the n power, it's the same as n times the log of u. In other words, what's happening is you can bring that power down to the front as a coefficient. And that's pretty crazy. It actually follows directly from the first rule. So if I have the log base a of x squared, for example, I could think of that as the log base a of x times x, right? Because x squared is just x times x. So if I use the product property, that's log base a of x plus log base a of x, and that's the same as 2 times log base a of x, because there's 2 of them. And so you can see that what happened if I, followed that process through is that the power became a coefficient. So the power property is really just an extension of the product property. Okay, so when we're using these rules with logarithms, it's usually called condensing and expanding. So sometimes our problem gives us, a couple of logs in an expression, and it wants us to condense them into one log with a coefficient of 1. So we don't want any numbers in front, and we only want a single log. That's called condensing. Sometimes our problem gives us a single log and wants us to spread it out or expand it into as many logs as possible. We actually use expanding of logs a lot in calculus because it makes our calculus a little bit easier. And so whenever we're using these rules, the base that you're in will stay the same throughout the problem, and it will either be condensing or expanding. So let's do a few examples. This one says, find the exact value of each log without using a calculator. So I've got a couple of logs here. We are going to use condensing to help us. So I have a log subtract another log, so I'm going to use this quotient property to condense it together. So log base 7 of 2 minus log base 7 of 98 is the same as log base 7 of 2 over 98. Well, 2 over 98 is reducible, and it's 1 over 49. So log base 7 of 1 over 49. Remember, with logs, we're just thinking about what power. So in our head, we're kind of thinking about what power of 7 gives us the answer 1 over 49. Well, you probably recognize that 49 is 7 squared, but the 49 is in the bottom, so we need a negative with that 2 to move it to the bottom of to move it into the quotient. So our answer is log base 7 of 1 over 49 is equal to negative 2. All right, this next one, log base 5 of 5, the cube root of 5. Remember that roots are the same as fraction powers. The square root is the same as a 1/2 power. A cube root is the same as a 1/3 power. So I'm going to think of this cube root as a 1/3 power. And my log rule, my log rule, I'm going to use that bottom log rule. If we have a power, I'm actually using expanding here, we can bring it down to the front. So this is 1/3 log base 5 of 5. Well, log base 5 of 5 is the same as thinking about 5 to what power gives me 5. And so log base 5 of 5 is just 1. So this is 1/3 multiplied by 1, which is 1/3. Okay, so now we're going to try to expand these logs. So it says write each log in terms of log 2 and log 3. So what we're going to do is think about 6 as 2 multiplied by 3. So we have the log of 2 times 3, which is a product. We're going to expand it into a log plus another log. So this will be the natural log of 2 plus the natural log of 3. And we're done. We wrote it in terms of log 2 and log 3. For the next example, we've got quotient, so we are going to use subtraction of the two logs. The log of the top minus the log of the bottom. So we have a log 2 there, that's good, but we don't have a log 3. We need to think of the natural log of 27. Well, we need to think of 27 as 3 to the 3rd power. And in that way, we can use our exponent rule. So we have the natural log of 2 minus 3 times the natural log of 3. All right, so that was expanding. Let's expand a little bit more, but this time just with some variables. So I have the log base 2 of 8 times by x times by y. So we're going to kind of use that log property of the log product property. We're going to expand it, and because we have 3 things being multiplied together, we're going to expand it into 3 logs. So this is the same as the log base 2 of 8 plus the log base 2 of x plus the log base 2 of y. Now this first one, you might notice we can actually simplify. Remember, logs are just asking us to think about powers. So this is asking us what power of 2 gives us 8, and that power is 3. So this is actually the same as 3 plus log base 2 of x plus log base 2 of y. All right, our next one, log base 7 of y over z. We're going to use the quotient rule. So we're going to do a log minus a log. The log of the top minus the log of the bottom. And that's done. Okay, our last one has a product and it has some powers. I'm going to use the product rule first to separate that into a log plus another log. So this is the same as log base 5 of x to the 7th plus log base 5 of y to the 3rd. And now I'm going to use the power rule to bring those powers down. 7 log base 5 of x plus 3 log base 5 of y. A lot of times people can just do that in one step and not write out that intermediate step. If you're doing that, that's just fine. Okay, one more to expand. It has a square root in it and it has a quotient. So we're going to think of that square root as a 1/2 power. And we're going to use the quotient rule first. So this is the natural log of 3x minus 5 to the 1/2 power. So the log of the top minus the log of the bottom. And now we can use our power rule. So that will be 1/2 times the natural log of 3x minus 5 minus the natural log of 7. Now, please note, there is no rule that helps me to separate this. I cannot separate this. Sometimes students will be like, hey, can't we do the natural log of 3x minus the natural log of 5? And we can't. If you think about our rules, this is the natural log of 3x over 5. We cannot separate the log of subtraction. You don't see a rule that looks like this. Well, there's nothing. You can't do it. Leave it. So if you have the log of a plus b, just leave it. You cannot do anything to simplify that. Okay, so our answer was finished as is. So just be careful not to try to spread that log out. Okay, now we're going to do a little bit of condensing and then we're finished. So for the condensing, we're just kind of going the other way. We're starting with multiple logs. Our goal is to get a single log with a coefficient of 1. So the first thing I do when I'm condensing is powers go up. So that's going to be a y to the 3rd power. And then I can think about if my logs are being added or subtracted. In this case, they're being added, so it's going to be a product inside my log. So this is log base 2 of x, y to the 3rd. And you don't really need the parentheses there. I just put some parentheses. And it's fine with parentheses. Okay, let's do that again. So powers up, 1/2 power and a 3rd power. So I've got the log of x to the 1/2 power plus the log of x plus 1 to the 3rd power. Again, that's a sum, so it's going to be the log of the product, x to the 1/2 multiplied by x plus 1 to the 3rd. The more complicated the inside of the log, the more likely I am to put it in parentheses. Another way you could write this is that it's the log of root x times x plus 1 to the 3rd. And again, probably in parentheses because it's getting pretty complicated in there. Okay, so this last one. Sometimes people start, well, let's see, powers up. Sometimes people start a string of logs like this and they're like, okay, I've got the natural log of x plus 2 squared, and it's minus log x, so I'll put an x on the bottom, and minus log y, so I'll put that over y, and plus 3 log z to the 3rd, so here's a z to the 3rd, and it starts to look really garbagey. And that's a technical term, very garbagey. So what I would say is don't get into this weird complex fraction world. It looks terrible and it's hard to simplify, it's hard to deal with. So what you want to do is when you're condensing, You're just going to have a top and a bottom. You're just going to have a numerator and a denominator. And the sign of each of the logs tells you whether its argument is going to be in the top or the bottom. So this one is positive, so that x plus 2 squared is going to be on top. The next log is negative, so its argument is going in the bottom. The next log is negative, so its argument is going in the bottom. And the last log is positive, so its argument is going in the top. And that is a much nicer looking log than that other thing that I erased a second ago. So kind of just think about it's the log of a numerator over a denominator and just decide where each part, goes in the top or the bottom. All right, so that's it. The assignment is in the book, section 3.3 on page 223. Let me know what questions come up. Logs are really weird to work with at first, so if it takes your brain a few days to really get it, don't worry about it. You're going to get it. You are a great math student. But if it's challenging and weird for you to think about these, that's pretty normal, and you will definitely get the hang of it. So just keep working hard. Thanks so much.